guys, it's Mrs. Cameron here. I'm taking a look at the CLT practice test number 1. These are the formulas given on the test, and I had a student make a request for some further explanation on a few questions, so that's going to be my first video. So I'm going to jump ahead to question number 84. Actually, I saw quite a few students while you guys were doing this practice in class were like, what in the world is that box, Mrs. Cameron? That's wild. Why is that there? Well, that's there to make something that's actually kind of easy look more difficult than it is. So we're just going to treat this like a function, right? If a box is defined such that x box y equals 2x minus 3y, which of the following is equivalent to negative 2 box 2. So what we're going to do here is just plug in where there's an x, where there's an x, we're going to plug in this negative 2, and where there's a y, we're going to plug in a positive 2. So I'm going to rewrite this right here. 2 times x, but instead of x, I'm putting that negative 2 because that was at the front, minus 3 times y, and instead of y, I'm putting positive 2 because that was at the back. And now positive 2 times negative 2, a positive times a negative is a negative. 2 times 2 is 4, minus 3 times 2 is 6. We're at negative 4, and we go back 6 more. So we're going to be at negative 10, right? The signs are the same, so really we add the numbers, and then it stays negative. The correct answer for number 84 was indeed B. The next question on the list was number 87. And it says, what is the third term in the following sequence? So looking here, it's kind of hard to tell what is going on with these numbers. So it took me a few minutes of looking at this, more than I would want to spend if I was actually on a Saturday taking my CLT exam. The denominator's 36, 25, 16, we don't know, and 4, and I just kind of forgot about the 1. And then I said, okay, now what do I know about these numbers? 4, 16, 25, 36. Like, I'm not adding the same number each time. I'm not multiplying by the same number each time. What I do know is that 6 times 6 equals 36. I know 5 times 5 equals 25. I know 4 times 4 equals 16. Skip, I know 2 times 2 equals 4. So what's missing here is 2, 4, 5, 6 is 3 times 3 equals 9. And sure enough, I've got a denominator of 9 available for option A, and that is the correct answer. So they're looking for you to know your perfect square numbers and kind of have that memorized for question number 87. And then number 88, they factored out 3xyz, or they factored out 3xyz to the power of 3. And they factored it. They didn't completely factor it. They could have factored a little farther here, but they didn't. So we've got to look and see, okay, well, which one's equivalent? So I would just kind of go for the distributive property here and say, okay, what's this and this, right? 3 times 4 does give us our 12. X times no x gives us our x is good. Y times y gives us our y squared. And z times z to the power of 5 does give us our z to the power of 6. So far here, the front is good. And now we check the back. 3 times indivisible 1 is 3. X times x is x squared. Y times y to the power of 3 is y to the power of 4. And then here at the end, z times z to the power of 6 would be z to the power of 7, not z to the power of 9. So right here, we got a problem. A is not it. But the good news is that answer choice B is almost the same as A. So if everything at the front was good there, right? Z to the power of 3, z to the power of 3 gives us that z to the power of 6 at the front. So that's fine. The only thing that changed was the z, so z is the only thing we need to check. And the z still works for the front. And does the z work for the back? We know the 3, the x, and the y are fine. Z to the power of 3 times z to the power of 6. You add the exponents, it's z to the power of 9. This is where we have the full match at B. So, right, 3xyz cubed times 4yz cubed plus xy cubed z to the power of 6, double checking. 3 times 4 is 12, no other x. Y and y is y squared. Z3, z3, z to the power of 6. 3 times 1, 3. X times x is x squared. Y and 3 more y makes y to the power of 4. And then z to the power of 3 times z to the power of 6 is z to the power of 9. That is a match. And moving on, nothing on the next page. Our next request was number 98. For a biology class, you are calculating how much growth medium it will take to refill the class set of agar plates. Each agar plate is a cylinder. With a base that has a radius of 5 centimeters. Radius is 5, and a height is 2 centimeters. There are 30 agar plates in the class set. To refill them, you need enough growth medium to fill each plate halfway. How much growth medium in centimeters cubed will you need? So right here, centimeters cubed, I know that I am finding the volume of a three-dimensional figure. So my volume, oops, my volume of the cylinder is going to be the area of the base times the height. So the area of my circle, they give us the formula for that on the reference sheet. The area of a circle is pi r squared, and then to find the volume times the height. And now I know that I have 30 of them, so the volume of the growth medium that I need is going to be, I need 30 of these things, right? Because there's 30 plates. The height is 2, but I only need to fill it halfway. So half of 2, my height it needs to be filled up to is just going to be 1 centimeter times my radius squared, 5 squared. 5 squared equals 5 times 5 equals 25. And all of that times pi. So really I just have to multiply 30 times 25, and then all of them have pi on the end. So 25 times 30, remember no calculator on this test. 3 times 5, 15, 3 times 2, 6, plus 1, 750. Pi is the answer. Look at that, it was C. And then I had a request for number 99, but that's trigonometry. That's a question for another video. Number 102 was also a question. That's trigonometry again. That's a question for another video. And then number 104, back in Mrs. Cameron's comfort zone, we got some geometry here. Triangle CGD is congruent to triangle FGD. If the perimeter of CGD is 12 and DF equals 5, so our perimeter here is 12. DF is 5. What is the area of triangle CDF? Okay, so I know this is 5. These triangles are congruent, so if this hypotenuse is 5, this hypotenuse over here is also 5. I know we can say that this down here is x. I know that these 3 sides have to add up to 12. So I know that 12 equals 5 plus x plus something. I can take 5 away from both sides. When I take away 5 here, this disappears. And 12 minus 5 is 7 equals x plus my other side is going to be 7 minus x. So that's my three sides. So this right here, this shared leg of my two triangles is going to be 7 minus x. Now to find the area of triangle CDF. Okay, so I can use my Pythagorean theorem to find out what x is by setting up a squared plus b squared equals c squared. So these sides are my a and b, right? It doesn't really matter which is which, because we just need to find the area of the triangle, and we can make it work either way. So a and b are my unknown sides. So x squared plus 7 minus x squared equals our hypotenuse squared, which is 5 squared. And now I need to clean this side up and find out what are my zeros. So we got x squared over on the side. I'm going to multiply 7 minus x, 7 minus, oops, x. And 7 times 7 is 49. 7 times negative x minus 7x. 7 times negative x minus 7x. And negative x times negative x becomes positive x squared. So I can put these together. And I'm going to put this one first, plus x squared. And then I'm going to combine these two. Negative 7 minus 7 minus 14x. And then on the end, plus 49. And then to save myself a little bit of time, 5 squared, 5 times 5 equals 25. I can subtract 25 on both sides of my equal sign. Minus 25, and that's going to put all of this as equal to 0. And now I can simplify a little bit. X squared plus x squared is 2x squared minus 14x. And 49 minus 25 is 24. Plus 24 equals 0. All of these are even, so I can factor out a 2. 2 times x squared. 14 divided by 2 minus 7x plus 24 divided by 2 plus 12 equals 0. And now I can factor this out. I know it's x and x, and looks like two negatives. So two numbers that add up to 7 and multiply to 12. I know 1 times 12 is 12, but 1 plus 12 is not 7. 2 times 6 is 12, but 2 plus 6 is not 7. 3 times 4 is 12. 3 times 4 is 12. And 3 plus 4 is 7. So these are my factors here, and I can prove it really fast. I wouldn't do this on the CLT because it's a time test. But I'd get x squared minus 3x minus 4x positive 12. Negative times a negative positive. So we got 2 times x minus 3 times x minus 4 equals 0. So I know that these sides over here are 3 and 4 because that's when x equals 0. So I can get rid of this, and I'll call this one 3, and I'll call this one 4. And the area of a triangle, I don't know if they give you this formula or if you have to know it. Area of a triangle, they do give it to you. The area of a triangle is on your reference sheet here. It is 1/2 base times height. Go back, purple. So area equals 1/2 base times height. So our triangle here and our base and our height are 3 and 4. So that's why it didn't really matter which was 3, which was 4, which was x, which was 7 minus x. It's fine. 1/2 of 3 times 4. So I'm going to actually multiply 1/2 of 4, which is 2, times 3 is 6. And CDF. So, sorry. So that's my area of this side of the triangle is 6, and they want the area of CDF. CDF. So that's both. So if the area of this triangle on this side is 6, then the area on this side is also 6. Put them together, our area is 12. And that is the correct answer. Sorry for spacing out a minute there. And let me see what else was on my request list. Number 112 and 115. Okay, so number 112, if n is greater than 0 and n to the power of y over n to the power of 1/3 equals 1 over n to the power of 3, what is the value of y? So right here, I'm going to rewrite this, and I've got n to the power of y, and since these two variables, right, are the same, but their exponents are different, and we're dividing, when we're dividing variables with different exponents, we can just subtract the exponents. So that's n to the power of y minus 1/3 equals n to the power of negative 3. If I rewrite this like this, then I know that y minus 1/3 equals negative 3, and I can solve for y now because there's only one variable and I got rid of the end. So right here, I'm gonna want to add 1/3 to both sides of my equation. So y equals, right, because I'm adding 1/3 to both sides, plus 1/3 plus 1/3 equals, now my negative 3 equals to how much over, I want my denominator to be 3. Right now, the invisible number for my denominator is a 1. 1 turns to 3 by multiplying by 3. Whatever I do to the bottom, I gotta do to the top, times 3. So negative 3 times 3 is negative 9. So I've got negative 9/3 plus 1/3. So y equals negative 9 plus 1. Denominators are the same, so we can add them, right? Signs are different, so you subtract. 9 minus 1 is 8, but the negative number was bigger, so it's negative 8/3, and B is the correct answer for number 112. And then number 115 was the last not trigonometry request. Okay, number 115. A walkway is paved with tiles in the pattern shown below. The dimensions of the walkway are 5 by 175 tiles. How many dark tiles are there in the walkway? So I can see my 5. Going this way, right? 1. Oh, what will let me highlight there? Highlight. 1, 2, 3, 4, 5, right? So we got the 5, but they did not show us all 75 going across. So 75 goes all the way across, but they're not all here because they skipped some stuff in the pattern. So we've got to kind of break this up. And I can see the front here and the back here is not a repeating part of the pattern. But everything in the middle, you have ba ba da ba ba ba, goes like this. Starts at the bottom to here. So I'm going to come to this right here. This section repeats a certain amount of times, and then it stops right here because it doesn't finish the pattern again. So this is repeated how many times? There's 75 total tiles going by this way. So we got 1, 2, 3, 4 here. 1, 2, 3, 4 in our repeating pattern. 4 on the end. 3 in this not repeating pattern. So we got to take these and find out how many times does this pattern repeat. So we have 4, plus 4 times however many times the pattern repeats, plus 3 plus 4. Okay, so this has to add to 75. So 75, and I know 4 and 4 is 8, and 3 is 11. So 75 minus 11, I have 64. So I know my pattern is repeating 64 divided by, there's 4 patterns, there's 4 tiles in there. 4 goes into 64. 6 goes into 4 one time, minus 4 is 2. Bring down the 4. 4 goes into 24 6 times, no remainder. So the pattern repeats 16 times. So in this set of 4, I have 3, 6, 9 dark tiles. And on the ends, I have 9 dark tiles. In this little section that doesn't repeat, I have 1, 2, 3, 4, 5 dark tiles. And then in this section that repeats 16 times, I have 16 times 1, 2, 3, 4, 5, 6, 7, 8 dark tiles. And 16 times 8, 8 times 6, 40. 8 times 1, 8 plus 4, 128. So I've got 128 plus 9 plus 9 is 18, plus 5 is 23, plus 23, 8 plus 3, 11, 2, 4, 5, 151. So the answer is D. On a 45-minute test, that is a lot of work for one question. And okay, and last, oh no, 118 was a trig question, so I'm going to skip that for now.